Ideally, the manufacturing process to create a product would produce an identical match to the CAD model or engineering drawings. Realistically, however, this is not always the case. When working with injection molded plastic, a number of influences can cause minor or extreme variations, like deflection and part defects, within the manufactured part. This is where Autodesk Moldflow Insight can help. By digitally simulating the injection molding process, steps can be taken to optimize the part geometry, tool geometry, and process settings to help improve the manufactured part's quality. Part quality includes items like specified dimensions and visual aesthetics, so when molding a part, it is important to understand the effects process changes have towards these. Moldflow Insight has an easy-to-set-up simulation for a design of experiments, often referred to as a DOE, that can help the analyst with understanding these. Instead of tying up resources to run a DOE at the press, and then trying to interpret the tremendous amount of data that it produces, Moldflow DOE results provide a filterable summary table, informative log, and interactive graphs for easier interpretation. In this example, an automotive glove box door simulation points to an issue with sink marks. With the designs already frozen by the OEM, process adjustments such as changing temperatures, pressures, and injection time would be the best option for sink mark depth reduction to a more acceptable level without having to make costly tooling changes. After specifying a design of experiments within the optimization choices, Moldflow launches a wizard to help the analyst step through the setup. Notice there are several types of DOEs available: one variable, Taguchi, face-centered cubic, and variable influences then responses. We'll focus on the variable influences then responses in this example, which is a hybrid combining the Taguchi and face-centered cubic, since we aren't quite certain which variables are the most influential for sink marks, but still want to review through the response plots. The number of top influences to be used to compare the responses can also be controlled here. With this type of DOE, any number of variables can be chosen on the following page, but only the top 4 influencing variables will be analyzed against quality criteria. It is important to keep an eye on the number of analyses listed at the bottom left corner of the dialog, as it represents the number of analyses Moldflow will run through within the DOE. More variables means more analyses, thus a longer solve time. With melt and mold temperatures selected, along with injection time, pack pressure, and overall cycle time, pinpointing which variables are the main influencers of sink mark depth can be observed. Although we're only looking into the reduction of sink mark depth, adding additional quality criteria helps identify if making changes to reduce sink mark depth will also result in other concerns. We'll add cycle time, injection pressure, and warpage to confirm the part remains in tolerance and machine pressure is not maxed out. After running the analysis within Moldflow, the summary table provides the analyst control to filter the many process options to only those with acceptable sink mark depths. It also shows the other quality criteria for a high-level look at how those are influenced by the process settings chosen for the reduced sink mark depth. Further details on the ranking of the influence of each variable in the DOE can be found within the log. In this example, notice how it indicates pack pressure is the highest. Reviewing the sink mark DOE response plot, the Z-axis displays the sink mark depth, while the X and Y axes are the variables with the highest impacts influencing sink marks. The remaining variables are then set to single data points, which can be altered to experiment with the different combinations. These plots are also a way to visually identify how significant a change like drop in melt temperature can impact the part quality, helping the analyst build a robust process window in order to allow for some changes at the press if needed. Incorporating the ability to troubleshoot upfront using Autodesk Moldflow Insight's design of experiments narrows the scope of experiments that need completed at the press by focusing the processor only on those settings that influence change.